Good day, folks. Welcome to Mind Academy, where we bring pillars to every lesson. Let's look at question 4 for May, June 2024 question paper. Should be very beautiful and easy. Given the graph of g of x is equal to that, so this is a hyperbola. Okay? Before I go anywhere, let's analyze the hyperbola. The value of a here is greater than 0. So it means I'm going to draw on quadrant 1 and quadrant 3. And then I have the asymptote at x, it is equal to 1, okay, as well as y, it is equal to 2. And then I'm done. Remember, when they want me the equation of the axis of symmetry, I take this. Axis of symmetry with a positive gradient. With a positive gradient, I'm going to just take x minus 1. I'm going to say y is equal to x minus 1 plus 2. This one has a positive gradient. With a negative gradient, I'm going to say negative into x minus 1 plus 2. This one with a negative gradient. Where gradient is greater than 0, this one is when gradient is less than 0, negative or positive. So I think that's all. We'll see. It says, write down the equation of G. So write down the equation of the asymptote of G. These are the asymptotes, guys. X is equal to 1 and y is equal to 2. Easy. Easy. And just say and, not or. If you do not know these words, just use a comma, guys, and leave into the net. Draw a graph of G indicating any intercept with the axis and the asymptotes and all of that. Okay. It's very easy to draw. Why? Because I know the quadrants and I know the what. I just need, before I draw, let me find the x-intercept. For x-intercept, I let y equal to 0, guys, you know. Right? So when I do that, it's going to be 0, it is equal to 1 minus x minus 1 plus 2, negative 2 is equal to 1 into x minus 1. And then when I multiply this to the other side, it's going to be negative 2 into x minus 1. It is equal to 1, and then x minus 1, it is equal to, divided by negative 2, 1 divided by negative 2, and then x is equal to negative half plus 1, which is half. So I have the x-intercept at half and 0. Let me look at the y-intercept if it exists. Remember, for y-intercept, I just let x equal to 0. X equal to 0. So it's going to be 1 minus 1 divided by negative 1, which is negative 1 plus 1, which is just 1. So my y-intercept is going to be what? X is 0, y is 1. And then remember the asymptotes, x is equal to 1 and y is equal to 2. I'm going to show you guys. It's very easy to draw this graph. Just do this. Do that. And then it's just a matter of you, before drawing any sketch, just say this is x, this is y. My asymptote, it is y is equal to 2. I can put it anywhere, guys. I don't need to be, as long as I indicate this is 2, and then x it is equal to 1. Okay, I think, let me redraw this in a beautiful manner, guys. Now I like to indicate here y is equal to 2, or you can put it here 2. And then the other one, it is x is equal to 1. Okay, and then I just need to draw. I said I'm going to draw on quadrant mark 1. So where's quadrant 1? Here's quadrant 1. These are now my quadrants, looking at the asymptotes. No longer this one, but looking at the asymptotes, it's this. And then the other one is going to be okay. And then I know here, okay, my y-intercept is supposed to be at 1 somewhere. So 1 is supposed to cut somewhere in the middle, and then, yeah. So this one is 1, guys, and this one is half. Remember the y-intercept, it is 0 and 1. X-intercept, it is half and 0. So it's that. And then just say this is the graph of f. Beautiful. You don't need to stress yourself here. I'm done. And then they say to me, determine values of x where g of x is greater than 0. G of x greater than 0. G of x, where is it above? Is this the graph of g, or guys? This is the graph of g. Where is g of x above? The what? The thing there. It is above here. It is also above there. So which values of x, guys? The values of x is that it's above from negative infinity to what? To half. To half. It is above. I'm using this one because the examiner did not include it. Okay. And is it that the only solution? No. Also where? Or also from where? From where our asymptote, remember, okay, I forgot to put my asymptote here, it is x is equal to 1. My asymptote, from my asymptote to positive infinity, or from my asymptote, which is 1, to positive infinity. Can you see that, guys? They are above there on those two portions. Very easy, isn't it? And then they say to me, determine the equation of the axis of symmetry with a negative gradient. I know with a negative gradient, it's going to pass here. It's going to pass at the point of intersection here. It's going to pass there. And remember, what are the coordinates of the point of intersection? The point of intersection, its coordinates are just your axis of symmetry. The point of contact is just 1, and y is equal to 2. Okay, so, and remember, it is the equation, it is y is equal to, if it has a negative gradient, it is negative x plus c. The one with a positive gradient is going to just be like this. Does not want to form a straight line, guys. Yeah. With y is equal to positive gradient x plus c. So you can substitute y is equal to 2x, okay, x is equal to 1 plus c, and then you'll see it will be 3. Therefore, it will be y is equal to negative x plus 3. But what I like to do is that come here. Here is the axis of symmetry. Here. With a negative gradient, you just say negative into x minus 1 and then plus 2. Don't forget it is y. And then it's going to be negative x. Then negative by negative, it is plus 1 plus 2. So it is negative x plus 3. Can you see it's the same? With a negative gradient, I get what? Negative x plus 3. It is also the same thing when you use y is equal to mx plus c, guys. Very beautifully the same. So this is very beautiful, guys. Very beautiful, guys. So yeah, that's the one for May, June 2024, question 4. Let's move on to question 5. Hopefully you'll enjoy it also. Thank you.